Hello students, how are you? This is Unupal sir once again. Today we will discuss important conceptions regarding SN1 and SN2 mechanism, aliphatic nucleophilic substitution. Do you know what is meant by nucleophile? Nucleophile means which can donate their electrons to any positive center. So if you have any minus charge like OH minus, NH2 minus, Cn minus, you are nucleophile. But you are also nucleophile if you have lone pair. You may not have minus charge, but if you have lone pair of electrons like H2O, like ammonia. H2O has two lone pairs, ammonia has one lone pair, so it can also donate electrons. So H2O, ammonia, they are the examples of neutral nucleophile. Look at that, neutral nucleophile, because they are having lone pairs. But charged nucleophiles, OH minus, Cn minus, F minus, I minus, all of them are charged nucleophiles. They are neutral nucleophiles and they are charged nucleophile. Okay? And what is meant by electrophile? Electrophile means you have the ability to accept electrons. So for that, you should have a positive charge. Obviously, you should have a positive charge. So they are called charged electrophile, isn't it? Or you may have vacant orbitals, BCl3, BF3, AlCl3. They have vacant orbitals. Okay, so these are known as neutral electrophiles. Neutral electrophiles. So I hope you got it, the idea. What is meant by nucleophile? What is meant by electrophile? Now come to the SN1 part. And don't forget to watch the video of the RS prediction of the chiral carbons. Because in this video, that conception is very much mandatory. Okay, so let's start. SN1. SN1 means what? That is nucleophilic substitution, unimolecular. Unimolecular. Okay, why I am telling you now? This goes via two steps. One is formation of carbo-cations, and the second step is attack by nucleophile. Please listen carefully. One is formation of carbo-cation and second one is attack by nucleophile. So, if it has R group like that and one halogen atom, maybe it's fluorine, chlorine, bromine, iodine, whatever. So, if three R groups are different and one halogen is also different groups, so this carbon is now chiral carbon because four different groups are attached with it, isn't it? So it is optically active carbon, optically active compound. So now when you are giving H2O, you are giving H2O, then what is happening here? It will give you OH. It will give you OH. Instead of this X, it will give you OH. And KX will be eliminated. Okay, so if basic medium is there, dilute form OH minus is there, dilute form, then it will give you OH like that. So how it is going? Now I will tell you. So first step is formation of carbo-cation. So one carbo-cation should be formed. Now say for example, this X, I have considering this X is present above the plane. It may be below the plane, but I am considering it is above the plane. Then you know, now the carbon atom is sp3 hybridized because 4 sigma bonds are there, sigma, 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 sp3 hybridized. But now it becomes sp2 hybridized. 3 sigma bonds are there, 1, 2, 3. So sp2 hybridized. So sp2 means it becomes planar structure. It becomes planar structure and it will have its vacant orbital like that. So in this vacant orbital, H2O can attack. In this vacant orbital, H2O can also attack. Okay? In this vacant orbital, H2O can attack. In this vacant orbital, H2O can attack from another side. Because H2O doesn't know where the X was. Okay? So, you will have two products. One is like that, and one is like that. If X was above the plane and the nucleophile also occupied the same position, then its configuration becomes same. If it was stereochemically R, then the product is also R. Or if it was S, then the product is also S. So in this case, retention of configuration is maintained. That is why, please note down this, it is known as retention of configuration. Because leaving group, where the position was, and nucleophile has occupied same position. But now, in this case, leaving group where the position is above the plane, but the nucleophile has come opposite side. Because sp2 means planar, so nucleophile can come in any side. So it is known as inversion. It is known as inversion of configuration. If it was R, then the product will be S. If it was S, then the product will be R. Got it? If you have not watched the RS nomenclature, please have a look at that. You will understand all these things. So in case of SN1, this can also be happen, inversion. This can also be happen. That is why this mixture is known as racemization. So write down, in case of SN1, racemization occurs. Racemization occurs. Why? This is the reason. Got it? And among these two, between these two steps, first step is the slowest one. And slowest step is known as the rate determining step. From chemical kinetics, you know that. So, rate of the reaction is directly proportional to the substrate only, not the concentration of nucleophile. The rate of the SN1 reaction is independent of the concentration of nucleophile, because nucleophile is coming in the less important step. This is the most important step as it is the slowest step. First step is the slowest step. Got it? So, rate equals to K substrate to the power 1. That means you know it is a first order reaction. Okay? So, if we draw the graph of T half concentration like chemical kinetics, then it will follow first order reaction. That is why SN1 means unimolecular. Is it clear? Now we need to draw the energy profile diagram of SN1 reaction. Got it? Let's start. So if it is reactant, if it is product, then it will move via two steps. This is transition state 1 and this is transition state 2. Why? Because first step, I have told you that first step is slowest step. So slowest step के लिए activation energy का value ज़्यादा होता है. Chemical kinetics concept from Arrhenius concept. So this is the EA1, that is for first step. Okay? And that is slowest step. This is fastest. तो first step के लिए activation energy कम होगा, इसलिए वो ज़्यादा faster manner में होगा. Have I made myself clear? So SN1 is first order and that is the energy profile diagram. Y-axis is energy and x-axis is reaction coordinate. Rate of reaction coordinate. Got it? SN1 किसमें फेवरेबल होगा? क्योंकि हमें मालूम है कार्बोकैटायन का जो स्टेबिलिटी होता है वो 3 डिग्री ग्रेटर देन 2 डिग्री ग्रेटर देन 1 डिग्री. तो इसलिए SN1 का रेट 3 डिग्री कार्बोकैटायन में ज्यादा होगा, फिर सेकेंडरी, फिर 1 डिग्री. चलो एक एग्जांपल ले लेते हैं कि सपोज द क्वेश्चन इज गिवन this will give SN1 in a faster rate or this will give SN1 in a faster rate. So obviously it depends on the substrate. If this carbocation is forming, then it will form 3 degree carbocation. If this carbocation is forming, then it will form only 1 degree carbocation. After elimination of this chlorine, you will get what? You will get this 1 degree. And after elimination of this chlorine, in this case, you will get 3 degree. So 3 degree carbocation is much more stable because it is supported by the Plassai effect of 3 methyl groups, and here the support is only 1. So that is why 3 degree carbocation SN1 is much higher than 2 degree, much higher than 1 degree. Got it? And if polar protic solvent is there, polar protic solvent like water, किसे कहते हैं polar protic solvent? What is meant by polar protic solvent? Polar protic solvent means, you can write it down, which can dissolve the cation as well as anion. Cation as well as anion. Water can solvate both of them. So that is why in this case formation of carbocation is there. So polar protic solvent favors rate of SN1. Okay? But sometimes rearrangement may take place. Let us consider an example. Rearrangement take place if the substrate is like that. H2 is there. Okay, then if formation of carbo-cation is there, like the first step, that will be formed, but you know what is the degree of that carbo-cation? Only it is attached with one carbon, so it is 1 degree. It is 1 degree carbo-cation, and hence it is less stable. So what the thing will be happening? This will shift the hydrogen towards itself. This hydrogen will be shifted to this carbon. Why? Because now it will form 3 degree carbo-cation. That was 1 degree, but that was 3 degree. So which one is more stable? It is more stable. Now attack will take place and you will have your product tertiary butanol. You will have your product tertiary butanol. So if anyone doesn't know the idea about the mechanism, then he or she cannot predict the original product. So what are the salient features of SN1? We have seen 3 degree greater than 2 degree greater than 1 degree, that is the stability of carbo-cation order. So SN1, rate of SN1 also will be like that. Polar protic solvent like H2O favors SN1, and rearrangement may take place. And if nucleophile is weak, note down this point, if nucleophile is weak, like H2, H2 is weak nucleophile. Why? Because it doesn't have any minus charge, only it can attack with the lone pair. So it is weak nucleophile, weak nucleophile. If weak nucleophile is there, then SN1 is favored. Got my point? And in case of SN1, retention may also happen, inversion may also happen. So racemization takes place. Okay. Now come to the SN2 part. SN2 means bimolecular because it is second order. Write down the salient features. SN2, that is rate is directly proportional to the substrate and the nucleophile. Because when nucleophile is strong, then SN2 is going to happen. Because before the formation of carbo-cation, it will attack. Note down please, before the formation of carbo-cation, it will attack. Okay, so SN2 is one step reaction, and here backside attack, that is 180 degree attack, takes place with respect to leaving group. With respect to leaving group, 180 degree attack is going to take place. So let us see. Aqueous KOH is there. Then OH minus will attack from this side and X will be just substituted. So here you can get the product like that. Because X was above the plane, here backside attack taking place. So that is why OH minus will occupy the below the plane position. Isn't it? If it was below the plane, then OH minus will come above the plane. Isn't it? So there is no formation of carbo-cation only one step process, that is the rate determining step. So nucleophile concentration, the rate of this reaction is dependent on the concentration of nucleophile. So that is why this is 1,1. That means it will follow second order reaction. Second order. So if it is chiral carbon, that means what? That means 4 different groups are there. So there inversion is taking place. Mind it, in case of SN1, retention and inversion both can take place, but in case of SN2, inversion only is going to take place. And as the nucleophile is strong nucleophile, OH minus as minus strong nucleophile, that is why it will attack before the formation of carbo-cation. Okay? So in case of polar aprotic solvent, SN1 favors, but polar aprotic solvent like methyl cyanide, acetone, dimethyl formamide, all these will favor SN2. And if the substrate is tertiary, then SN2 is not going to happen. Why? Because if the substrate is tertiary, then there will be huge repulsion from the backside attack. That is why it is not going to happen. Okay? So salient features of SN2, what we can write? We can conclude that if the substrate is primary, then SN2 attack is going to take place. If the solvent is polar aprotic, then SN2 attack is going to take place. And if the nucleophile is strong, then also SN2 attack will be favored. Got it? And what will be the energy profile diagram in this case? Only one step is there, reactant product transition state. Only one step is there. Okay? So this is the end of this video. In this video, I have discussed some important conception regarding SN1 and SN2. In my next video, I will discuss how can you predict whether the compound is going to give SN1 or whether the compound is going to give SN2 reaction with more complex examples in a simplified way. Thank you for watching. If you think that it is to be liked and shared, then please do.